right, let's get to it. Cool. So first question is, why is my IDE not showing up? Let's solve that. There we go. That looks better. Interesting. Okay. Cool. We are continuing to refactor Glyphos. Haven't done a demo in a while. Still not going to do one this time. If you look back 2 or 3 VODs, there should be a demo at the beginning if you want to see what Glyphos is all about. But we've just been working through this massive refactor, and I'm going to get through it. I want to do it fast. This is my giant French press of coffee that I will be consuming over the next 2 hours as I burn this refactor down. So we're just going to jump into it. So I did a little work off stream, just doing some basic fixing of compiler errors, and was working through implementing this validation function, which basically for the binary symbol tree needs to make sure that the type map, so like it needs to make sure that there aren't ambiguous types, and it needs to make sure that there aren't ambiguous arities. Arities are like if you have f of x, y, z as a thing, this has arity 3. Because x, y, and z are the arguments. There are 3 arguments. So f of x has arity 1. Q some x has arity 0. Right? F of this has arity 0. How many children you have in the symbol tree, essentially. Started to work through that and then got pulled away. So we'll pick up there, and we'll just try to burn down a bunch of methods we have to implement. So how is this working? So getArities needs to return a hash map from the labels to the, I think this can be symbol name, to the arity, which is a usize, or it throws an error. So we go through the node trees, so that's going to be the labels mapped to where the labels are. And I was going to do this by getting the indices, but I think actually what I want to do is just say, so I was going to have a get arity that looks up based on the index, but I think it should just be based on the label. Symbol name. So this won't be necessary, and we'll do this in a moment. I'm gonna close some things on my desktop. It feels a little bit laggy. Don't need that. Don't need that. Okay. So we'll say getArity will take a label, and then it's gonna end up doing something like this, and it's going to return a result of usize or SymbolNode error. And here we'll have let indices be self.get indices label. this. Try to use good alias. I mean, symbol name is just a string, but it's nice to use. Nice to use some aliases to let the caller know what they're meant to put in there. I should probably be doing it for these U sizes too. Okay, so this isn't going to work now. So here we'll have for index in indices. Let's see. I wonder if this is what we want to do. Do we actually want to get the indices and then loop through them? Because that actually passes through the bit twice. We could just go through it directly. Yeah, I think we probably want to do that. Okay, so this is going to be more like let encoding be self.node trees dot get label dot or not or else map or what's the one that I always forget these methods? Okay or yeah, okay or I always forget the ones that go between result and option. They like the names are good, they just do not stick in my head. Okay, or error, symbol node, error, no such label. Okay, we can kick that out. And then let's just go 0 through encoding, 0 through self.length in bits. Dot into iter.map I. I could do this as an accumulator, but actually, let's not. I think it's going to be more readable if we just say for I in 0, self.length in bits. Let's say let mute to return is 0. Is fine. In theory, we maybe also have to check that. Let's see here. If encoding binary encoding dot 0 return error, SymbolNode error, binary tree, we'll say invalid node tree label. We'll create some new error types based on these. Okay, so now we know that this is always going to loop at least, or trigger at least once, so it doesn't really matter what we initialize this to. Doesn't matter. Guaranteed to be written, overwritten once. Otherwise, I might make that an option and then ensure that it's not none at the end. If encoding dot get, is it get bit? Get bit from the left. Self dot length in bits. In theory, we can, I guess we can say let length in bits equal self dot length in bits. Do the same thing here. Okay, and then we're looking at the ith bit. So if it's set, then we need to get the arity, and we'll do that by get arity from index I. Oh, this actually does matter. Okay. Because we're not going to know whether it has had arity 0 already or not. We could carry another flag around, but it's easier to just do it as a let new arity be this, and now match or if let some old arity equals to return, if old arity not equal to new arity, then return error SymbolNode error. Conflicting arities. And we're just gonna change this to use the label. I don't think I need to carry around the whole SymbolNode every time. Otherwise, we have a new arity that's guaranteed to be the same. So arity matches don't need to replace it. Else to return is some new arity. And then down here, okay. New, no, okay, to return, dot expect, to return is guaranteed to have been written at least once. Yeah. And we're returning that, so no semicolon. Okay. mismatch types, expected bool, found option. Huh? Yeah, you don't need, okay, it doesn't even know. Okay, and now function get arity from index, self usize, I is a usize, and it returns a usize. And this is just gonna go, do we want to return a result from this too, actually? Probably. Unless we want to make it unsafe and panic, which it's a private function. I think it's okay. Okay, and so this is just gonna go if self dot is left paren I plus 1, can that panic? Unwrap or false. Then we have to calculate the arity, otherwise return 0. Because that just means it's not opening any brackets. And then here we want to say let left paren index be I plus 1, let right paren index be self dot get matching right parenthesis left paren index. Do I need to put in the length? No. Okay. And now I can just take the difference between these things, right? So we'll say expect parens should be balanced. And now the difference between these indices is the arity. Is that true? So if we had like f of x, y, z, then left would be 0, 1, right would be 0, 1, 2, 3, 4, 5. So it's minus 1. So return right paren index minus left paren index minus 1. Okay. And these can be like this. Slightly more idiomatic. Okay. Cool. What's this problem? No field 0. Fair. Okay, and then we need invalid tree node on SymbolNode error. Okay, and so now get arities just becomes way more straightforward. Because now we can just do, can't we just do this in one call now? Self.node trees.iter.map label encoding which we don't even need. Self.get arity label. Oh, the only problem here is that the results don't want to. I think this isn't going to work because it doesn't like the closure, right? Or does this work? I think it doesn't like the question mark in here because it's inside a closure. And so then I can use map. I can use try map, I think. Something like that. But it's kind of ugly. Okay, let's do it as a loop then. I think it's cleaner, more readable. For label nothing in self.nodes. Self.get arity. See here. Let arity be self.get arity label. This is, no, actually that's fine. To return dot insert label arity. Expected string string. Thought this would. That would be a reference, but okay. Cool. Didn't I do invalid node tree already? Felt like I did that. Invalid, oh. Node tree is correct. And then what was the other one? No such label. Okay. Ooh. Equals versus double equals, that's not a common bug for me. Oh, I gotta plunge my coffee. Sweet mana of the gods. Okay. Couldn't convert the error. So, okay, or... Oh, this probably doesn't want to be wrapped in error, right? It's a sneaky bug. It's one of those ones that you can spend a long time trying to fight with the type system on because you don't realize it's double wrapped. Mismatched type. Sure, we can clone this. this also. Clone this also. Did I already change the type of that? Conflicting symbol arities. Did not. And then symbol arities. That one's fine. This one's fine. This one's not fine. Get name. Get root as string. Okay. Can't move out of self. I don't want to. Okay. I actually thought that it would default to .iter here. Probably bad that I didn't know that. To return hosts. Okay, this needs to be cloned. It's fine. There's nothing you can do about that. Encoding. Node trees get. Okay. I believe you. Same issue. Okay. Let's go see what's going on in transformation that it's yelling at me about. Okay, fine. Let's. While we wait for the IDE to catch up. Can't move out of self. Why is this moving anything? Ugh, no. It needs to be a reference. I have a cool idea for when this refactor is done. I think I'm gonna write a script that just generates for every shared function. Between SymbolNode and binary symbol tree. Write a test that just instantiates it and like does the intos and make sure that they result in consistent answers. In theory, it could even be a fuzz test where we randomly generate the inputs, although I'm not sure it's worth the extra complexity to do that. But that's kind of a cool thing about optimizing this way, where you write the basic naive implementation first, and then you find out it's too slow, and then you write a new version with the same interface. That's going to be faster. Okay, I don't want to do these predicate ones now unless I need to. Replace our predicates. Okay, get relabeling. We're going to want to do and get typed relabeling. All right, let's find out what. Let's actually just commit one more time here. Get arity should be good. Get relabeling. Okay, so the relabeling is just saying, and again, this should really be symbol name to symbol name. So relabeling is saying, I give you two symbol nodes, the one I'm calling this on and another one. What would I need to do in order to map one into the other? And so I think we want to implement this from scratch for binary symbol tree because it's going to be a lot easier to do with a binary symbol tree. This is one of these methods that just gets way easier. So with binary symbol tree, we can do a bunch of checks. Yeah, this is going to be way easier. So let's go to binary symbol tree, and let's go, I don't know, here-ish. Here-ish. Get relabeling. Those are fine. And so, so all we really need to do is check that there exists like an isomorphism, like a one-to-one map between the node trees that respects types, and then everything else is the same. So if self.length in bits not equal to other dot length in bits, return error, symbol node error, length, okay, symbol nodes, we'll just say conflicting lengths. Self.length in bits, other.length in bits. If self.left parens doesn't equal other.left parens, return error, symbol node error, conflicting parentheses, this is fine. Oops, this is like this, or self.right parens not equal to other.right parens. Okay. All right, so now there can be different numbers of symbol. Ooh, okay, that gets a little more complicated. Because you could have a relabeling, you could have like x equals y and x equals x, and then what you want is you want the map to be x to x and y to x. Is that how it works right now? Can that happen? Probably. Relabeling not injective is a thing. Sure. Meaning you can't go the other way. So if you were trying to go the other way, you would have two different keys that, or the same key would try to map to two different values, which doesn't work. Okay. So I guess the best thing to do is just to go through. It's like still a little slow, but for self label, self encoding in self.node trees.iter. This can be real slow. I don't want to do it that way. I want to do it a better way. What's the better way? It probably still starts that way, but then I don't have to loop through every one of these. So the point is that it should be easy to prove that the relabeling isn't going to work. And so we want to hit that case as soon as possible. And so what I want to do is if I had some encoding like this, I want to notice that this bit is set and then immediately throw out all possibilities for the relabeling that don't have this bit set. Which should be really fast. Because if I and self-encoding with other encoding, and I don't get self-label back, then it can't be a remapping. So naively, there would be something like for other label, other encoding in other.node trees.iter. If self-label self-encoding and other encoding equals self-encoding, to return dot insert self-label other label, right? Because if self-encoding and other encoding is equal to self-encoding, that means self-encoding is a strict subset, or is a, not strict, but is a subset of other encoding, which means it's a map. if to return dot contains self label return error SymbolNode error injective. What about injective? Fine map. So go very detailed error. So we'll say let map equal, or let mute map equal to return dot into iter dot collect as a vec map dot push self label other label. And something's got to get cloned in here. Clone. Clone. And this needs to be cloned too. Okay. So we're still going through a lot of contains key, right? And our parentheses are bad here. It's interesting that equals takes precedence over and. Also, this should be binary and. Oh, it doesn't take precedence over and. The problem was that it wanted Boolean and. Got it. Okay, and then we need conflicting lengths and conflicting parentheses. No implementation. I'm not going to be able to do this, am I? I don't think I can just dereference these. These are stack. I can just dereference it. Okay, I don't understand how that works at all. I think I'm gonna get yelled at once the compiler gets further, but like the right way to do that is to just implement. Let's just do it the right way. The right way to do it is to implement and for the references. Binary and the thing. Binary encoding. Add bit and. For binary encoding. Okay. And we'll do the same thing for OR. And I guess we should probably do the same thing for XOR also, even though I can't imagine ever using XOR. I mean, I can. I have a vivid imagination. I can imagine doing that. Okay. What? I can't return it. Yeah, that's reasonable. That's not what you expect, right? All right, let's look at the docs. So what is binary encoding? It's a big U int. Big U int Rust. Traits. Add bit and okay, it just returns a normal. This is what I need to get rid of. Binary encoding. Expected a reference. Why does it expect a reference? That seems wrong. Oh, it shouldn't be self. Got it. Because self is a reference there. I get it. I will not be outfoxed by this Rust compiler. I refuse. Have I been outfoxed? I have been outfoxed, but I will re-infoxify myself. I will put the fox back within. Oh, I can just say it. I can just say self here. Bit or. Okay. All right, what were we doing when we started shaving that yak? Right, mismatch types. Okay, conflicting parentheses we need, and you know what I want to get better at is using splits. This seems like a good moment to use a split. Use a horizontal split. Well, that didn't work. Oh, there we go, that worked. And then let's go SymbolNode error. Conflicted right parentheses, conflicting parentheses. Okay. And conflicting lengths, size. Ooh. Okay. All right, I think we're happy about that. So the other one was get typed relabeling. Oh, wait. We need to check something else. We need to check that the types and the arities match. I guess the arities automatically match. So we want to say if self dot node self.nodes.get self label unwrap. I mean, we know this exists. What to say? Say let self type self.nodes.get self label.expect. We know the label exists. .get evaluates to type. And then same thing, but for other. If self type doesn't equal other type, then actually there's another problem too. Okay, I think the way to do this actually is to say if this equals other type, then do all this stuff. And then down here we have to make sure that every relabeling applies. Which maybe we can do here. Let bound map bound relabeling equals false, and then before we turn around we say if not found relabeling return error symbol node error relabeling missing labels, missing label, self label. Okay. And here we say relabeling missing label symbol name. This also should be symbol name. Symbol name. Okay. The other one was get typed relabeling. What is this? This uses substitutions. What's the difference? Does this not care about types? Is this actually ever used? Yes, it is. What is it used for? Relabel and transform. Do we ever use relabel and transform? Pretty unclear that we do, but okay. Okay. What did we do about substitution? Seems like we haven't implemented anything around substitution yet. I need more coffee. Okay, so I think substitution. So substitution is this type that sort of just wraps symbol name So substitution wraps a substitution, which is a map from a label to a symbol node. It's sort of a problem for me. I think what we want to do for this, and also probably for predicate, which has the same basic structure, is redo this in terms of binary symbol tree. And then we'll just update SymbolNode to turn itself into a binary symbol tree before using this. I'm not really sure that my approach, I don't know. I think I tried to get tricky with aliasing types to make this refactor easier, and I think I might have made it more complicated for myself. But whatever. In for a penny, in for a pound. Okay, let's... All right, let's do it. Binary symbol tree. Binary symbol tree. Binary symbol tree. Symbol node. Okay, I think this part might change. So we're not going to use the addresses anymore. Yeah. Sort by. Yeah, we want to just use replace node. Okay, yeah, there's a subtle thing that goes on here, though, where you need to replace the deepest addresses first. You have to go as deep into the tree as possible to replace stuff, because otherwise you can end up replacing something first. You need to do the replacements in the right order, is the point. I know we implemented replace node. Oh, no, we didn't. Do we need a new replace node? So if I were just implementing this to start with, so substitute takes a statement and then it applies the substitution. But it does need to happen at the deepest levels first. Why does it have to happen that way? Why can't I just go left to right? I think I can. I think I can. So I think this is just, I think we can get rid of this. Famous last words. And then this becomes something like let mute I equals 0 while I is less than, that's not right. Need to return the statement. While I is less than to return dot length in bits. To return dot replace substitute at or replace at replace node replace at I hang on, if yeah, the problem is I can't just do it as binary operations. And I can't just go through the substitutions and apply them because I might double apply substitutions that I don't want to do. Which is why I was doing a depth first when I had an actual tree. But if I walk the statement, the problem is that to check each bit, I have to check each node, each set of node trees. I guess it's not like disastrous. This is a pretty hot part of the code path, though, I would think. Should be, yeah, it should be very hot, actually. Because these substitutions are happening every time we try to do anything. Every time we try to transform anything, these substitutes are happening. So I don't really want to chase a bunch of pointers. I really just want to go through the substitutions one by one. But the problem is I could have a case like substitutions is like x to y and y to z. Statement is like x plus y. And now we end up in a weird situation where statement becomes where we go x plus y to y plus y to z plus z, which isn't what we want. And there's not necessarily like in this case, you can have a well-ordered, if you go through these in the right order, you'll wind up with the right answer, but it's not necessarily well defined. Which is why the way I'd done this before was to go through it depth-wise. If we go through it flat, it works because we decide, like, we replace x first, but then we never re-replace x. But we have to chase the substitution pointers every time. It's not, like, tragically bad. I guess the problem is we have to chase the node trees pointers every time, which is tragically bad. We could filter node trees first based on what's in the statement. That'd be better. Oh, okay, what if we come up with all the indices that are going to get substituted? That's the way to do it. That's the way to do it. So we'll just say statement. So now, yeah, this is gonna be better. Let mute to substitute is going to be a hash map for I in 0 through statement dot, no, wrong, for label new tree in self dot substitution. So the point is we're just going to come up with where the substitutions are. We're not going to apply them, and then we'll go through and apply them in one pass. Match statement dot node trees dot get label. Man, we can do better than that. We can just say if some encoding is this, then let indices be statement.get indices label. I don't actually have to write this. To substitute dot extend label. Into hang on, get indices is a vec. Okay, cool. So yeah, dot into iter dot map label I dot collect, and then to substitute dot extend indices, and the borrow checker is gonna, well, I think I just got some of these interfaces wrong, but the type checker will catch me. Okay, so now wait, that's not right. We want it to be a map from I to new tree. We're still like constructing a map, which isn't thrilling from a speed perspective, but I don't really see how we do it any other way. Okay, now for index replacement. I think we actually want this to be a vector. And then we'll say to substitute dot sort by AB A dot 0 A dot B dot 0 dot CMP A dot 0. So we're going to sort them by their indices descending. So we're descending by indices. And then for index replacement, into substitute to return dot replace at, replace node, replace at index replacement. Let me to return equals binary symbol tree. New, yeah, new. And now to return. Yeah. I think. I believe. This is wrong. This should be statement.clone. And this is going to be a vec of usize and binary symbol tree. Okay. So we need to replace at. And I feel like I already did something along these lines. Didn't I? Get Aries, sure. Get indices, get type map. Says symbol is root. Why is he yelling at me about all of these? Kid is upstairs banging on a drum or something. I assume that doesn't come through the mic, but if it does, I apologize. Get types, get symbol in order, get relabeling, substatement, relabel to avoid, relabel all. Here we go, with child replaced. Okay, here's where I did the merging. So I think I want to reuse this logic. With child replaced. So if I just take this and I go with child replaced at, make this private, and now call this replace from index. Get rid of this and do self dot with child replaced at replace from index new child. And then I go back here, what is going on with my ID, and I say with child replaced at. And I think it's okay that it's private because I think I can call a private method from within the same file, but I can't remember. I can make it public if I need to. Like sort of okay exposing that. Why is my IDE losing its mind? Oh boy. Did I miss a bracket? Sure did. That would explain why the IDE is losing its mind. Huh? Confused. How did I miss the end of this so badly? I gotta figure out what this used to look like. Source, SymbolNode with child replaced. I'm on the wrong branch. Replaced. Okay, big long thing, and at the end, node trees.insert. Okay, somehow I missed this. Okay, making progress. Okay, yeah, so a couple of these are gonna run into problems. We want this to be .into. This is just because now we've changed the interface on substitutions. I shouldn't say it when I update these because it makes... Probably need to clone. Mismatch types, that one's okay. Cannot move out of right hand side. Self. I don't want to. Self.0 has type big ant. Okay, what if I do this? No, I will save to get it to rerun. Move out of right hand side. That's okay. We'll do this. think this should be good. Because then we don't have to move them because we're just borrowing them. Yep, good. Fix it here also. Not there. Here. Okay, that should be the 3 places. Feel like we're making progress. We're gonna have to do a really similar thing for predicates. Type needed. I get it. I think this also needs to be mute. I think this needs to be at mute, and then I think indices needs to be mute. This probably also needs to be cloned. Yep. Believe this is how this works. We good? Not quite. Type mismatch. Expected tuple. Bound mute. Okay, so indices has the type I expected to. To substitute has the type I expected to. Is it just this? I really thought it had to be a mutable reference. I can check. Oh, it does not. Self has to be mutable. Great. Okay, and then here, to return is moved. Sure. I don't want to clone it. Hang on, what if we do to return? No. To substitute for each index replacement to return dot with child replaced at index replacement. Definitely needs to be muted. trying to figure out if this is provably. Actually, not sure what the. Yeah. Oh. Wait, this shouldn't be returning anything. I have to iter this, right? And now with child replaced, could be a reference. Should just be a reference because this is gonna get cloned anyway, right? New child encoding is getting cloned. Yeah, we're cloning in here anyway. It may as well be a reference. Okay, so I assume that's going to cause me some problems. Expected U size. It's fine to dereference. Just copy anyway. Okay, why getting moved? It's moved in the closure. Captured by that. Trying to work out why it thinks it's getting. Like, isn't it provably getting borrowed once? Feels like within this scope, it's only ever getting borrowed once. But trying to see what the idiomatic way to do this. Think this does any better, does it? I think this is where I started, but now it's gonna like isn't it not gonna like this because it's it's use of mood value. Oh, we take it by self. That's the problem. Okay, it returns every time, that's the thing. Okay. That makes more sense to me. That makes a lot more sense. Okay. Does this not return? Those can return an error, but this can't receive an error. So when does this ever return an error? Exactly when? Wait, actually though, when does this ever return an error? When combined nodes returns an error is the only time? Appears to be. Yeah. And combined nodes returns an error when right, ambiguous labels. Okay. We can just ensure that this never comes up. But we might need to optimize. Okay. Okay. I think I'm going to get to the bottom of any more compiler errors around this, and then I'll probably wrap it up for today. I feel like we made a bunch of progress though. Morning streams and coffee are good for progressing. And I think next time we'll look at, so there are predicates somewhere also. And predicates are basically going to have the same problem that substitution did, where we use SymbolNode all over the place, and we're going to want to re-implement it. I think predicate might actually be okay. Predicate, we might just go the other way and do it in terms of symbol nodes for now. All right. Cool. Predicate. Okay, so get type relabeling we'll need to deal with, and then this. What is C? What are we doing here? Ask. Transformed statement. Okay, that was because we changed the API. That's a nice change. That saves a clone. Implemented or converted substitution to use binary symbol tree. Okay. All right, I think we're good. We'll start with, I guess we'll need to do get type relabeling first. Next time, we'll start there. Okay, cool. Thanks for stopping by. If you stopped by, like, follow, subscribe, all those things. They help me out. Hopefully we'll probably in one more session, I expect to at least have everything compiling, and we'll probably have to do some work to generate some tests, and then we'll finally get a benchmark on this refactoring, which will be exciting and hopefully fast, because this has been quite the journey to get this refactored and hopefully optimized. All right, Thanks, I'll catch you later.